Hello everyone, I'm Vasu Bansal. I'm currently pursuing B.Tech third year from Maharaja Agrisane Institute of Technology. Currently, I'm making this video presentation on what I learned in my internship and projects. So first, I'd like to go through the content on what I learned about the project in my internship, and second, I'll show a demo about the project. So first, these are the contents: the C programming, then embedded systems, microcontrollers, tools used in project, and then I'll show you my project that is microcontroller based washing machine. So first, let's deep dive into what is C programming and what I learned in the internship about C programming. So first thing I learned was number systems. Now number systems generally are represented as decimals, octal, hexadecimal, or binary. They have a base of 10, 8, 16, or 2 respectively. They are represented like this, as you can show in the figure. Dec as 0 to 15, oct as 0 to 7, and then from 10 to 17, then 20 from 27, and so on. Hexadecimal goes from 0 to F, where A represents 10, B represents 11, and so on, as F represents 15. Binary, we show binary numbers in zeros and ones. So first, let's talk about binary. So the computer understands only two states, high state and low state, making it a binary system. So obviously we need to know about binary systems so that we can provide some basic information to the computers. So bit or binary digits are known as the basic units of information in computer. Let's go to byte, which is a unit of digital information, which consists of 8 bits and is the smallest addressable unit of memory in computer. It is written like this. Now, word has a size of 32 bits or 4 bytes, and it is the amount of data a machine can fetch and process at a time. It is written like this. Now that we know a little bit about number systems, we'll jump from number systems to data types. So basic data types. The basic data types are of 4, as you can show here: char, int, float, and double. In which char represents characters, int represents a number, float represents a number in a fraction or point, for example 3.4, 3.14, etc, and so on. Now we go from data types to data type modifiers and qualifiers. Modifiers can be of two types. One is size, which have 3 options: long, short, and long. While it can also be signed and unsigned. Unsigned values are those which are only positive or 0. Signed values are those which can be positive as well as negative. So this is all about data types. We are not diving deep into data types. We'll talk about briefly about all what I learned in C types. So next is conditional constructs. So conditional constructs can be of two types if we need a single iteration or multiple iterations. So for single iterations we can use if else or switch case. For multiple iterations it is for while and do while. So let's go through them one by one of each: if else, switch, and all of them. First, if else. Now this is the syntax we use for the if else. Now if the condition that we are providing here is true, a code is executed. If not, else statement is executed and the code moves on. This is if else. Now in switch we provide an expression and cases. There are multiple cases that we provide. If one case is true, the code is executed and we provide a break, which makes which puts us out of the switch loop. Otherwise, if it is not false, it will check this next statement and next until if all the cases are not true, a default case would be executed and then we'll come out of the switch. This is how the syntax of the switch works and the flowchart. Now, after knowing single iterations, we'll move on to the multiple iterations. In multiple iterations, we have while. Now, while loop is very interesting because if we need to execute a code repetitively, we use while, do while, or for. So, in while, it checks the condition. If it's true, the code is executed, and then again it checks the condition. It keeps on doing this until the condition is false. If the condition is false, it will move on. It will come out of the loop and move on. It is same for the do while. The only difference in while and do while is first the code is executed, then the condition is checked. This happens so the code will be executed once, regardless if the condition is true or false. It is useful in many cases for, as we can see in an example like this. Now, for loop works same as while loop. This is the syntax and an example of the for loop. Now, what we need to learn now is continue and break. So in continue, a continue statement causes a jump to the loop continuum portion. For example, what happens is if the code is executed and condition is checked for the continue, if it's true, the code will be skipped. Now, this is a syntax that we use for the continue. We'll move forward to break. Now, break is a statement which is used to exit the loop. The statement appears after break and the loop will be skipped. So, if the condition for the break comes true, we come out of the loop. The loop will not execute anymore, and the code will move on. Now, we have learned all about conditional structures, and we'll move forward to operators. Operators can be of multiple types: logical operators, arithmetic operators, bitwise operators, and many more. We'll look into all of them one by one. First is logical operator. So logical operator can be three: logical not, logical and logical or. So this is the example of we using the operators logical, or, and nor. We'll move forward. The arithmetic operators are nothing but multiplication, division, modulo, addition, and subtraction. We know all about these. Modulo is used, except modulo is used to get the remainder. For example, if we do 10 modulo 3, so we'll get the remainder 1. So it will show the answer 1. Now, this is the example of the modulo used, and we'll move forward. Now, relational operators. Relational operators tells us about the relation between the two variables which we have chosen, or whatever thing we want to find a relation of. So these are the operators we use: greater than, less than, greater than, equal to, less than, equal to, and so on. These are very useful when finding a relation between two variables or anything else. Now, bitwise operators. Bitwise operators contains bitwise and, bitwise or, bitwise XOR, complement, shift right, and shift left. Okay, now we'll go forth and learn about ternary operators. Now, ternary operators are of two types: overflow and underflow. Let's understand them. So in a 8-bit integral type can hold a certain range of values, and the certain ranges is 128 and minus 128 obviously. Above that and below that there is overflow or underflow. Pointers and arrays. Now these are very important. Arrays, why? First of all, this is the syntax we use for the arrays. Example is given here. I'll explain what is arrays. Now, array is a collection of data of same data type. The address are sequential, and obviously we saw in the examples the address of the first array and address is the lowest, while the address of the last array is the highest. Now we have taken an int, so that's why the base address of first and second have a difference of 4, and all the next array to its previous array have a difference of 4. If we have taken here car, it would have a difference of 2. Now we'll talk about pointers. Now, pointers, why do we need pointers, or what are pointers? Pointers point to the address to the variable you have stored it in. For example, we take a value x and we make a pointer pointing to x. So the pointer would store the address in which x's value is been stored. So pointer would contain 1000, as x is the value 5 of x is stored in address 1000. Now why do we need pointers? What is the use of pointers? So pointers are used because it can help in returning more than one value from a function or achieve similar results as passed by a variable. This is example showing how it is contained, the address. Okay. Now we'll go ahead and talk about functions. What is function? In programming languages, it is something that can perform a specific service. Generally, it has three parameters: input, operation, output. Now, let's dive deep and ask us, why do we need and why do we use functions? So we use it because it is reusable. It is used so that code can be easily understandable and modified. Functions can be easily debugged or tested. And a difficult problem can be divided into small sub-problems and solved using dividing and conquer techniques. So these are all the benefits of using functions. Now we'll talk about recursive functions. Now recursive is a process of repeating items in a similar manner. In programming, a function calling itself is a recursive function. Now this is an example of a recursive function. Now preprocessor, a header file used in C, for example hashtag include studio.h and so on, they contain C declarations and macro definitions to be shared between several source files. Whenever we use a header file, we include #include like this. This is called a preprocessor directive. Now why do we need these header files? They contain inbuilt libraries and macros which helps us in coding and getting a better understanding of what we are coding. Now the preprocessor header files can be of two types: header file and source file. A header file contains declarations which are shareable and reusable and used by more than one file, while source file contains functions and variable definitions which are not shareable. Moving forward, this is how we write the syntax of header files. If a header file is a system header file, the syntax is like this. If a header file is a local file made by you, we write it like this. Okay. Now, we have learned all about C programming and we have talked about it in brief. Now, moving forward, I will cover what is microcontrollers and what I learned about microcontrollers. So basically, I divided this into three parts: what is microcontroller versus microprocessor, as well as how do we choose a microcontroller. So first, let's dive deep into what is microcontroller. Microcontroller is an integrated circuit which is capable of being programmed to perform a specific task. It contains obviously restrictions are memory size, input output capabilities, peripheral functions, and so on. Now, what is the difference between microprocessors and microcontrollers? Now, microprocessors basically have all the components separately. It is simply a CPU and we connect all the components externally to it, which makes it more flexible but having more design complexity and can cost you more than a microcontroller. Now in microcontrollers, all the components are on a single chip, so it contains a CPU, memory, input output devices, peripheral devices, and so on a single chip. It is less flexible obviously because all of them are on a single chip, so you can't replace them with another ones. For example, if you need more memory, if you need more input output devices, you can't do it. You have to buy another chip. and it has less design complexity, costs less. No. Choosing a microcontroller. While choosing a microcontroller, we have to keep in mind the applications that we need it for, as well as what is the performance of that microcontroller. We need a microcontroller specific to our problem. It has to be within our price range and should be available. It should be available to us easily. If it is very difficult to find, it is not a good choice because it will hamper our ability to replace it if it gets damaged in some way. Obviously, special capabilities are also there. For example, if one microcontroller has more input, other one has more memory, but we need more inputs and outputs, so we will choose the first one. Now, moving forward, we'll talk about embedded systems. Now, embedded systems, we need, my whole project was on embedded systems, so we'll talk a little bit in briefly about it. First is the definition of embedded systems. Any combination of hardware and software which is intended to do a specific task is called an embedded systems. So it's a combination of hardware and software. Without one, you cannot call it embedded systems. Examples are here: your smartphone, a Mars rover, your washing machine, your TV, airplane, your car, etc. All of them are an example of embedded systems. Now, moving forward, we'll talk about the categories of embedded systems. These are standalone, real-time, connected, and mobile. We have covered all the categories. Moving forward is the components of embedded systems. Now, this is how generally embedded systems look like, containing a microcontroller, a microprocessor, connected with memory, and ASIC, that is a specific task integrated circuit. Sensors, if a sensor is providing a digital signal, then we don't need this. Otherwise, if it is providing an analog signal, we need an analog to digital converter. Now, all it is connected to actuators which need a digital to analog converter. If it is not, if it can perform on a digital, we don't need DAC. Otherwise, we need DAC. And above all of this comes into hardware, while we provide a software to form an embedded system. Now, what are the requirements of the embedded systems? First of all, it should be reliable, cost efficient, low power consumption, and it should have efficient usage of processing power. Lastly, it should have an efficient usable usage of memory. Now, challenges when we face in embedded systems are efficient inputs and outputs, embedding an OS, where code optimization and testing and debugging. These are the four challenges that we face in embedded systems. Going forward, the microcontroller that we used in our project was PIC16F877A. This is the PIC architecture that we used. Moving forward, we have learned all about what I did or what I learned in my internship. Now, moving forward, what I specifically learned for my project in the internship was: first, the tools used in the project are LEDs, digital keypad, interrupts, timers, switches, and CLCD. I'm gonna talk briefly about these topics. So first, this is the picsimulator we are using for our project. The project will be displayed on this. The demo of the project will be shown on a picsimulator like here. So moving forward, we'll first learn about what is LEDs. Now, obviously, LEDs is the simplest device used on most of the embedded systems as feedback. Now, obviously, LEDs are also known as light emitting diodes, which has huge applications in home lighting, remote control, surveillance, display, and many more. What is the correct working principles of LEDs? This is how we connect LEDs. LEDs can be connected in two ways: sourcing or circuiting. As we can see here, uh, on our Pixel lab, uh, on the circuit board, the LEDs are connected in connected like this, which makes them all sourcing LEDs, sourcing circuit LEDs. They are connected to port B and port D respectively, and we have 8 plus 8, 16 LEDs on our Pixel lab. Now moving forward from LEDs, we'll talk about digital keypads. Now in digital keypads, they provide simple and cheap interfaces. For example, and few of its applications are in HMI, mobile phones, computer mouses, and etc. These tactile switches that we use can be of two types or can be found two ways. For example, first is in pull-up circuit. The pull-up circuit looks like this. Connected to a controller, the connection goes to VDD and it's connected to a switch from here. As soon as we press the switch, the signal will flow from here. Sorry, from here to here. Otherwise, it's going from here to here. And pull-down circuit is the switch. The switch moves from here to here. So the signal are flowing here as the switch is not pressed. As soon as the switch is pressed, the current will flow from here to here. It can also flow there. That's why, to solve this problem, we connect a second resistor and make this value 10 times less than the first resistor. Now this is how the digital keypads are connected to the circuit board. All of these are connected in pull-up circuit ways. So if we press this, we have to press the switch, the signal will go to ground. Now we'll talk about interrupts. So interrupts is a communication process set up in a microprocessor or microcontroller, in which an internal external device requests the MPU to stop the processing. The MPU acknowledges the request, attends to the request, and goes back to process where it was interrupted. Now, this is the basic understanding of interrupts. Whenever we provide an interrupt in our program, whatever the program was going on is completed, and then it acknowledges the request and goes to the request with the help of this interrupt flag. Then this interrupt flag is set off, the request is completed, and it goes back to the what it was doing before interrupt. Now moving forward, this is a classification of interrupts. Interrupts can be of two types: hardware and software. Hardware interrupts can also be of two types: non-maskable and maskable, which can be external or internal. Now, this is how it is done. Interrupt occurs here, so it goes out to an interrupt handler ISR, attends to the request and goes back and performs its own program where it left off. Now we talked all about interrupts. Now we talk about timers. Now in timers, we four basic things that we need to understand are resolution, tick, quantum, and scaling. Now in a timer is in a form of register. In a form of register, the register length or the register width is the resolution of the timer. It can be a 8-bit, 16-bit, 32-bit. So if it is 16-bit, it has the value from 8. If it is a 8-bit, it has value from 0 to 256. The tick. Now tick represents if it is counting from 0 to 256 or 256 to 0, which is represented as up count or down count. Now quantum or the system clock settings tells us how much time it takes for one tick, which is 4 into the 4 times the amount of time it takes to complete one cycle. or it can be also written as 4 into 1 by f, which is the frequency using frequency of the pixel lab we are using, or controller we are using. Now last but not least is the pre-scaling. Pre-scaling is done to increase the time it takes for the timer to count. It is of two types, obviously, pre-scaling and post-scaling. Now diving deep, if this is a timer having a timer from 0 to 256, if we set a register from 250, if we set the register to 250, it will count from 0 to 250 only and then go back and start from 0. When this happens, this is called an overflow. An overflow, we count this overflow for our R usage. For example, if we take a timer with frequency 20 megahertz with no pre-scaling or post-scaling, the amount of overflow it takes to complete 1 second are 20,000. That's how we use timers to calculate time within the microcontroller. Now last topic about the tools is CLCD. Now CLCD are the most common used liquid crystal displays. It can display an ASCII character. It has two communication modes, 8-bit mode or 4-bit mode, which is known as byte mode or nibble mode. Now this is how it is connected to the circuit board. Going forward, we have seen all what I have learned in the internship and learned about the tools that we are going to use in our project. Now we'll look into what my project is, what its purpose is, requirements, and conclusion. Now, first, the purpose of this project. The project is microcontroller based washing machine simulator using PixelLab. Now we have made this washing machine using microcontrollers. So the purpose of this project is to focus on simulating a washing machine using PixelLab, aiming to replicate a real life washing machine functionality in a virtual environment. So the assumption is that we are using all virtual environment. No, we are not using any real time or real world machinery. Moving forward, this is as well. So as I said, the assumptions, all the peripherals are simulated and no real-time objects are interfaced. And the scope is to provide variable insights in washing machine operations, control system design, etc. This is the requirement, the functional requirement of a project. We need a microcontroller, and the four switches that are using are switch 5, switch 6, switch 4, and switch 1. Used for powering on for switch 5, pause or stop from switch 6, navigation from switch 4, and door status from switch 1. And the outputs that are used are the CLCD display, buzzer, and motor. Now going forward, firstly, when we start our simulation of a washing machine, as soon as we start the board, it will print press 5, key 5 to power on the washing machine. Now it will wait till we press switch 5 to show powering off washing machine. This is the output it will look like. The first power on screen, and as soon as we press the key 5, it will look like this. Now moving forward, as we do this, a washing program screen will display, which will contain a menu on the washing options. I mean, washing machine, all the options that we have given is daily, heavy, delicate, white, stain wash, eco cotton, woolen, bed sheets, rinse plus dry, dry only, and so on. Now in this programming screen, if we press switch 4, we can scroll between these options, and if we press switch 4 on the selected option for a long time, we will select that operation. It will look like this, and as soon as we select the option, we'll be forwarded to water level screen. Now in water level screen, we have a water level menu containing auto, low, medium, high and max. Again, we will use switch 4 to scroll between this menu, and if we press switch 4 for a long time, we'll select the highlighted option. Now this is how it will look like washing machine. As soon as we press it, it will show a function screen. It will show the start screen, sorry. And once the washing program and the water levels are selected, it will show the start screen containing a display of press switch 5 to start and switch 6 to stop. If switch 5 is pressed, it will display a function screen and start the functions. Otherwise, if switch 6 is pressed, it will go back to washing machine program screen. Now if switch 5 is pressed, it will show which program you selected. For example, if we selected heavy, it will show heavy and time it will take to wash your clothes. Now as soon as this switch 5 was pressed, after some time we'll get function screen. For example, switch 5 pressed, the screen was like this, and in the function screen we'll get, as an output, we will get function displayed of what the function is being used, which can be of three types: wash, rinse and spin. Based on the washing program and water level set, we'll see these functions. We'll see the time ticking down from how much it takes, and below it will be written switch 5 to start and switch 6 to press. Once switch 6 is pressed, the time would stop and washing machine would stop, and switch 5 is pressed, it will start from where it left off. There's also one catch, that is the status of switch 1 indicates door status. So in washing machine, if you open the door, the machine stops. So here, if you press keep on pressing on switch 1, it will indicate that the door is opened, and it will read a door, please close the door, door is open. Okay, and the buzzer will go off. Here it will be written like this. This is the function screen in which we will see, and here if the door is opened, it will write door open, please close. Now after all of this, once the time is up and the clothes has been washed, all of this would be having a complete status screen, that is, it will write program completed, remove clothes, which will look like this. So now I'll show the demo of what I told you about all in my description of my project. So this is the board of the picsimulator we are using. Here is the CLCD, and this is switch 1, switch 2, switch 3, switch 4, switch 5, switch 6. So here it is written press switch 5 to power on washing machine. So we press the switch 5, see, and we came to washing machine program. Once we came to washing machine program, as it was written here, after pressing switch 5 and going to washing machine program, we'll use switch 4 to scroll between the options. So these are the options given, and this is the switch 4. So clicking at switch 4, we scroll down the options and scroll between options. So after scrolling down, here, see, all the options are now starts repeating. Now we'll choose one option, heavy. Let's go to whites. So now we'll do a long press on switch 4 to select the program whites. As we have obtained whites, we are moved to water level screen, in which we have menu of auto, low, medium, high and max. So it is written switch 4 to scroll between again, and long press of switch 4 to select. So we'll choose any one of these. Let's choose max, and long press will select the option max in the water level. Now it is written switch 5, press switch 5 to start and switch 6 to stop. We are pressing switch 5 to start. Now it is saying whites, and time it will take is 1 minute and 16 seconds. Now function is going is wash. So as it was written here, start screen, as we pressed switch, it showed us this display and switch 5 was pressed, so it started the function screen. Now in function screen it is written there, if we press switch 5 it will start and switch 6 to pause. So we are pausing switch 6. The washing machine stopped, the motor is not rotating, and all the heat and the cooler is not going on, the time has stopped. So we are pressing switch 5 again to start the machine. Here the motor starts running again. Now as it is written here, we also have a door status. So if we press key 1, switch 1, which signifies the door status, it will open and buzzer will go off. So this is the switch 1. If we press it, the buzzer is off and the door is opened. So now as the functions are going from wash to rinse and the motor is spinning, all the functions are as it was in the PPT. It is working perfectly fine. We will wait till the timer goes off to see if the program has been completed as it should. So as soon as the program was completed, we saw program completed, remove close, and the buzzer went off. Now this is all about my project. Hope you liked it, and thank you for staying with me through all this recording. Have a nice day.